So let's have a quick look at the code, and then we won't go into every detail of it, but then we'll release the code and people can play around, maybe solve a few mazes. So I wrote this in Python because I fired up a debate last time I released some code in C#, but also Python does work very quickly on other people's machines. So, you can download this, install Python, have it running within a few minutes. So let's look at the code then. So this is my maze class, right? And most of this class is this constructor here, this initialization method, that takes the image, IM, and then walks through it, creating this graph structure. So all of these rules, so I have the first row which finds the start, and then I have at the bottom, I have the end row that finds the end. It was just easier to write them as a separate row than having test cases for the start and end throughout my code. And then within the loop, I just go for every single pixel on each row, and based on the previous square we were on, the current square we were on, and the next square we were on, I make a decision as to whether I need to create a node at that point and connect it to the left or above. That's all I do. And because I'm traveling down and right, all I have to focus on is creating nodes upwards and left, and they will all eventually connect to each other. That was my plan. Originally, I thought what I could do was do all the horizontal connections in one pass and then all the vertical connections in another. But then I realized I could do it in one pass and felt a bit smug. So we have path, path, path. So that's when we were on a path. Now we are also on a path, and so on. And we have, we create a node and we connect it to its neighbor, and so on. And we have different options for different nodes. Now, this actual node class is very straightforward. It just has its own position, because remember, once we're no longer referencing this image, we need to have some idea where they are, because for things like A star, we need to work out path distances and things like this. And then it has a list of neighbors. So a list of neighbors which are they start as none. None is equivalent of C# and C++ is null, which basically means there's no object there. Don't try and perform interesting functions on a none, because there isn't any. I'm not sure that's a fair point to say. Sometimes it's quite important that things are none. But the point is that if you get to a node and and lots of its neighbors are none, you don't have to go in that direction, because that means there's a wall there. If a neighbor is not none, it will point to another node. So this is a node object and this is a node object, and one of the neighbors of this object will be this one, and vice versa. So I can just move about between them very, very quickly. And then that's all really. And then in my solve algorithm, I time myself because I wanted to know how long these things take. I create the maze, and then I solve it using one of a few algorithms that I developed to solve it. So for example, in this case, breadth first. So we'll see if it works.